going to write a few basic covalent molecule, and then we will try to develop their shape, their bond angle, and so on. Okay, first of all, you will have to check the type of molecule. सबसे पहली बात तो यह है कि मैंने जैसे आपको बताया था कि आपने टाइप ऑफ मॉलिक्यूल्स चेक करनी है. क्या मॉलिक्यूल AP2 टाइप का है, then its shape will be linear and its bond angle will be equal to 180. So if the molecule is of AP3 type, then you will check the combination of bond pair versus lone pair. If there is no lone pair, all three bond pairs are over here, then the shape will be like that, like trigonal planar shape, and the bond angle will be equal to 120, roughly 120, approximately 120 degree. When there is one lone pair and there are two bond pairs left behind, then the bond angle is equal to not 120 and 118, 119 and 117. But you are not allowed to write 116. I mean, the last limit boundary is 117. So less than 120, or you can write the number 119, 118 and 117. So there are only two possibilities whenever you are going to check AP3 type molecules. So these are basically types of molecule, covalent molecule. So now come to the next one. If the type of molecule is AP4, I mean there is one central atom and there are total 4 pairs surrounding that central atom. So there are 3 possibilities, 3 basic main probabilities are the possibilities over here. 4 bond pair, all bond pair, no lone pair, then the bond angle is equal to 109.5 degree and the shape is said to be the tetrahedral shape. This shape is called tetrahedral shape. If there is one lone pair and rest of all bond pair, I mean 3 bond pair and 1 lone pair, then the bond angle is 107 degree, that is, I mean 2.5 less than that of 109.5 degree. So it is 107 degree and its shape is trigonal pyramidal. Its base is like trigon and its upper shape is like a pyramid. The next thing is as it is having the 2 lone pair and the 2 bond pair, and 2 lone pair, 2 bond pair, the bond angle is further decreased up to 2.5 degree, and the rest of bond angle, the smallest bond to bond angle is 104.5 degree. In this case, the molecule may be bent, may be angular, may be non-linear, and spatially we can call it V shape, so victory shape basically. So whenever you are going to have you are going to left with just 2 bond pairs. I mean, according to his rule, you will take 1 bond pair is equal to 1 pair, double bond is also 1 pair, and triple bond is also equal to 1 pair. So if you are left with the 2 bond pair only, then there are 2 basic chances. Either you will write it's linear, or you will write, I mean its bond angle will be 180 degree bond to bond angle, and its shape will be linear. Or the second other option is, if you are left with only 2 bond pairs, just have a look over here in this structure. So the bond angle may be less than, I mean bond angle is not 180 degree, then the shape may be bent, can be written as angular shape, and it may be or it can be called as non-linear shape. So if whenever you are not having 180 degree bond angle, and there are only 2 bonds left, so the shape is bent, shape is angular, shape is non-linear. Same is the case over here, 2 bond pairs left over here, and the bond angle is not 180 degree, then you can write bent, you can write angular, you can write non-linear. In addition to that, specifically in this case, you can write the shape of molecule that is called V shape, victory shape, and so on. Now come towards AP5 type molecule. Here is only one case as far as Cambridge A-level syllabus is concerned. Just all bond pairs are over here, no lone pair is to be considered. So the basic shape, the basic bond angle, the shape is, I mean the bond angles, there are 2 bond angles, 90 degree bond angles, and some bond angles are 120 bond angle. Overall, the shape of molecule is said to be trigonal bipyramidal. So its shape is trigonal bipyramidal. So basically, if you are going to draw this shape, then there are three lines. Those are lying at 120 degree, right? And two lines, those are, making 90 degree bond angle with these triangle. Let me change the color of my pen. I'm drawing with these line with the green pen. So these green line are basically vertically situated on the plane of these three bonds. These three bonds are lying at 120 degree, and this green line is lying at perpendicular position, at a 90 degree bond angle. So basically, this shape, roughly this is said to be one pyramid above, one pyramid below on this trigon or triangle shape. So it is said to be trigonal bipyramidal. So trigonal bipyramidal is the shape of the molecule whenever you are having the molecule like AP5 type. If the molecule is AP5 type, its central atom is A and it is surrounded by 5 pairs, and all pair must be the bond pair. So here is its shape. The last one, AP6. AP6 mean if there is one central atom and 6 pair of electron over here, then the shape will be tetrahedral shape. Tetrahedral, here I'm going to draw two basically dotted line, two dark wedges, and there are 4 bonds making 90 degree bond angle, and one above and one below the plane of this you can say square. This is the square basically. Overall, this shape that is made over here is said to be octahedral shape. Octahedral, 4 faces are over here. Octahedral mean 4 faces at the top, and similarly 4 faces are lying at the bottom. So this shape is composed up of overall 8 faces. 8 faces होते हैं इसके अंदर. So it is said to be octahedral shape. And here the most common bond angle, the most repeated bond angle is equal to 90 degree. So the bond angle is equal to 90 degrees. Shape is specific, that is said to be octahedral, and so on. So these all are possible shapes, options, bond angle as far as your syllabus is concerned. Got it? Now I'm going to again check the example. I'm going to solve an example to check SO2 molecule. So the first step is draw its Lewis diagram or Lewis structure. So there is a Lewis diagram, sulfur at the middle and double bond oxygen, double bond oxygen. Now the second step is let me write it over here on the next page. So sulfur at the middle, double bond oxygen, double bond oxygen. Now come towards the lone pair around the center atom. Sulfur is having total 6 electron in its last shell, and it has used or utilized 4 electron. So there is remaining 1 pair of electron. So overall molecule is having total, this molecule is AP3 type. 1 pair, 1 pair, 1 pair. 3 pairs are surrounding the central atom, AP3 type, and this is having 2 bond pair and 1 lone pair. So AP3 type molecule, 1 lone pair and 2 bond pair. 1 lone pair, 2 bond pair. So the actual shape will be like that. Bond angle will be less than 120 degree and 119 degree, let's suppose, and its shape is bent. It can be written as angular or it's non-linear, and so on. Now come towards another molecule. Let's suppose that is NH3. Again, I'm going to draw the Lewis diagram of NH3. having nitrogen atom is in the middle and hydrogens are lying at the corner. So this is the normal general shape of nitrogen and 3 hydrogen, I mean ammonia. 1 electron over here, 1 over here, 1 over here. 3 electron are used by the nitrogen atom, and there is 1 lone pair left behind because it is having total 5 electron in its last shell. 3 have been used in bonding, 1 is left behind, that is in form of a lone pair. So overall,
so this is AH3.
this is AP4 basically. Total pair is equal to AP4, and here there is a second category, 3 bond pair and 1 lone pair. So in this case it is pyramidal structure, nitrogen and 1 dotted line, 1 line dark wedge basically. This is the normal line. So hydrogen, hydrogen, hydrogen. So these 3 hydrogen are making a trigone basically, and it's having 1 lone pair. So the bond angle is, bond to bond angle is equal to 107 degree, and shape of molecule is trigonal, pyramidal or pyramid. So this shape is said to be like trigonal pyramidal, and bond angle is equal to 107 degrees Celsius. Let's talk about H2O, water molecule. So first of all, the Lewis structure, oxygen is in the middle and 2 hydrogen are over here, and
so this bond pair, lone pair.
how many lone pairs should be there on oxygen atom?
Sir, oxygen is 16, so 8, 2.
It is having basically 6 electron.
Yes, 6 electron. 1 is hydrogen, 2 hydrogen, so there will be 2 lone pairs.
Exactly. So 2 lone pairs are over here. So the type of molecule is basically P4 type.
P4.
Molecule. Correct. But this time it is having 2 lone pair and 2 bond pair. So that is having the lowest bond angle in this category, in this family, AP4 family you can say, and
105, right?
104.5, and this shape will be like that. 104.5. It's said to be V shape, I mean victory shape. It may be known as or called band shape. It is having angular shape, yes, it is true, and it is also said to be non-linear. Non-linear. And so on. So this is a scheme, and this is how you can predict the shape and bond angle, approximate accurate bond angle of different simple covalent molecule. Let's talk about an organic molecule. For example, I'm having this one, that is the famous acid used in our daily life, that is vinegar, and it's a covalent molecule. So I want to know the bond angle around this oxygen atom. Let's suppose it is X. I want to know the bond angle, this OCC. This it is written as OCC, mean C is at the center and oxygen and the carbon are surrounding this carbon atom. And same is the case, this one, this is said to be HCH. C is at the center, so HCH. Let's suppose it is equal to Z, and this one is the Y. So what are the values of X, Y, and Z? Again, I'm applying the same method because I have drawn a Lewis diagram first. So how many pairs surrounding this oxygen atom?
Sir, how many pairs? किस वाले के sir?
Oxygen.
Total.
Yes.
Sir, oxygen में. Sir, so there are 4 total.
4, good. And 2 lone pairs and 2 bond pair, right? So the bond angle will be equal to the lowest one in this category, that is 104.5 degree. Correct. What is a Y? I mean, let's see how many bond pairs are surrounding this carbon atom?
3 bond pair. There are no lone pairs, so it's 3.
Good. There is no lone pair. It is having all
It's
bond
AP3.
pairs, AP3, good, and simple AP3, and that is having 120-degree bond angle. This portion is said to be the planar portion. Whenever you are having the answer of bond angle that is equal to 120 degree, then you can write the shape. Finally, it's planar shape. It is known as a planar shape. उसके नाम के आखिर में आप word लगाएंगे planar. खैर. Now come towards Z. Come towards this couple.
Sir, it will be AP4 and it will be 90 degrees.
It is AP4, but it will be 109.5. मैंने 90 डिग्री तो AP4 में कोई बताया ही नहीं है.
हाँ है ही नहीं है 90 डिग्री. मैंने वैसे कुल वो 360 divided by 4 कर दिया.
Now come toward the next one. Another example that is also written in my book. POCl3. POCl3. So POCl3. Which one element is having the maximum valency? Phosphorus or oxygen? The normal valency of the phosphorus is 3. Oxygen is 2. Cl is equal to 1. So the phosphorus is having maximum valency among these 3. So I'm writing P in the middle. P and oxygen and Cl and Cl, Cl, and oxygen's valency must be satisfied is equal to 2. Valency of oxygen is equal to 2, so there must be 2 bonds surrounding the oxygen. And overall, phosphorus can make 1, 2, 3, 4, 5 bonds. Yes, it is true. So let's see how many lone pairs left behind on phosphorus atom at the moment. So
it will have 5. So it will have 2 over this. So it's equal. So this is AP4. And the bond angle will be equal as well. It will be 109.5.
Good boy. It's a AP4 type molecule and its bond angle is equal to 109.5 and its shape is said to be tetrahedral. Tetrahedral shape. Its shape is said to be tetrahedral. Now come towards another example. That is OF2. OF2. Once again, you will write its Lewis diagram. Obviously, oxygen is having 2 valency, so it will be in the middle. And F, 1 valency. F is also having 1 valency. Now come towards the next portion. Check the lone pair on the central atom. So we are basically focusing on the central atom every time. So 1 pair, 1 and 2 lone pairs left behind. So overall molecule, the type of molecule is?
Sir, it's AP4.
AP4, good. And
smallest angle, 104.5.
Good. Why? The bond angle is basically the second F will be over here rather than lying over here. So it's bonding. The smallest bond angle, smallest angle between the two OF bond is equal to 104.5 degree, and its shape is said to be V shape. V shape or bend shape or angular shape or non-linear shape. Now come towards the next example and hopefully you will do it yourself. And the example is ClF4, man. ClF4. ClF4. So come towards its Lewis diagram. In this case, you can see that
Cl hoga middle.
Cl at the middle is shabash. Good. And here are basically 4 F. Roughly I'm writing, this is not the exact shape. This is a rough diagram. And how many lone pair still yet intact with the Cl? If there are
Cl is in group 7.
Group 7, yes.
So there will be 1 lone pair.
Exactly. 1 lone pair, 1, 2, 3, 4, 5, 6, and 1 electron is also left behind over here.
what do we consider
one
of that
electron will not be considered as much as the lone pair is considered.
So it will be AP5.
So it's like AP5, roughly. AP5, yes, good boy. Just ignore, or you can consider this one. So its shape is basically, or you can write it as a distorted, or generally speaking, roughly speaking, that is not the exact shape. So its shape will be trigonal pyramids. So basically, if you are going to encounter with such type of molecule, you will write the shape according to your own syllabus. आपने सिर्फ वो ऑप्शन एक्सरसाइज करना है जो कि आपको आपके सिलेबस में बताया गया है. Definitely, this is not the exact shape. Its exact shape will be different. One lone pair and overall, 4 bond pair. तो जैसे जैसे lone pairs आते हैं, तो definitely there is, change in the bond angle. There is distortion of the bond angle. इसमें basically 2 bond angle होते हैं, 90 और 120. That is drawn in my book. और इसको सीसा शेप कहते हैं. But you will write the normal shape, the normal features according to your syllabus line, जो कि इस वक्त trigonal bipyramidal हैं, and roughly the bond angle will be equal to again basically 90 degree and 120 degree. So आपने अपनी डोमेन से बाहर नहीं जाना है. अनफॉर्चुनेटली अगर वो कोई सब कुछ ऐसा आपसे पूछ भी लें तो. Now come towards the last example in this sequence, that is IF5. IF5. So same halogens, 2 halogens, not same halogen, but both are halogens. They are making a new type of compound.
It's also group 7, so there will be 1 lone pair.
Correct, shabash. 1 lone pair. AP6 roughly, or you can say distorted octahedral, or roughly octahedral.
Sir, जो हमारे syllabus में है AP6, it should have all 6 bond pairs.
Yes, exactly.
And this has 5 bond pairs. No, it has.
Sorry. Yes, 5 bond pair and 1 lone pair.
And 1 lone pair.
Yes, its actual shape is square planar pyramidal, but you will draw it. You will write, or you will take the basic guideline of your syllabus, and that is octahedral, roughly octahedral, distorted, or roughly octahedral, and the bond angle will also be roughly equal to 90 degree. So आपने वही नाम लिखने हैं. आपसे पहले तो ये एग्जाम्पल शायद पूछी भी नहीं जाएंगी. अगर पूछी जाएंगी तो you are just bound to write the name as per your syllabus. So that's all about the practice of basic shape of simple covalent molecule in the light of VSEPR theory, valence electron pair repulsion theory guideline, and you will have to basically memorize these type of molecule according to my worksheet, according to my scheme. AP2 molecule, AP3, AP4, AP5. First of all, you will draw the Lewis diagram. It is a Lewis diagram. It is not exact diagram. फिर उस diagram से आपको पता चलेगा कि what is the type of that molecule. तो type, so diagram से आप type पे आएंगे. Type से आप combination पे आ सकते हैं. What is the combination I mean? तो उस combination के बाद you can move towards the shape of molecule, roughly known as geometry, and the bond angle between bond pairs of molecule. So step number 1 finally, step number 2, step number 3, and this is step number 4. So in this way, you can finally, you would be able to predict the exact or sometime rough name of the shape at the bond angle of the molecule. Got it?